Hello friends, in this video we will study the status word of 8251 Programmable Communication Interface, which is also known as USART. So let's start with our topic. So 8251, which is known as Programmable Communication Interface, that is PCI, also USART, that is Universal Synchronous Asynchronous Receiver Transmitter. So this 8251, it is used for receiving the data also and for transmitting the data also. Also this 8251, it performs the serial to parallel conversion and parallel to serial conversion. And this 8251, it is widely used whenever the microprocessor, it is communicating with the peripheral device which is at a long distance. So to transmit or receive the data from such peripheral devices, the 8251, it is used as a communication interface. Now, whenever we want to start this transmission or receiving of the data, or we can say that if we want to program this 8251, then we have to write the control words. And these control words, they are provided by the microprocessor. So control words, they decide that in which mode or what are the operations or functions performed by the 8251. So control words, they are always given by the microprocessor to the 8251 whereas these status word, whenever the microprocessor it wants to read the status of the 8251, the status of the flag registers or the status of the various pins of 8251, then it read the status through this status word. So in this video, we will study about the status word of 8251, that what are the 8 bits of these status word they define. Okay. So status word, it is read by the microprocessor to see the internal status of the 8251. So the format of status word is like it will have the 8 bits from D7 to D0, and all these 8 bits, they will define the status of some flags or some errors or some pins of the 8251. So from D7 to D0, will have the 8 bits. And when we define these 8 bits, that is called the format of the status word. So let's see that how these 8 bits are defined. So the 8 bits of the status word, they are defined like D0 to D7. We have D0 as TXRDY, that is transmitter ready. RXRDY, that is receiver ready. TXMT means transmitter empty. PEF is for parity error. OE is for overrun error. FE is for framing error. SYNDET, it is for sync detect or break detect. DSR is for data set ready. So these are the 8 bits of the status word which are defined like this: TXRDY, transmitter ready, receiver ready, transmitter empty, parity error, overrun error, framing error, and sync detect, break detect, or the data set ready. So you can see that in this status word we have the errors also, like framing, overrun, parity. We have the various pins of 8251 also, like transmitter, receiver. These are the pins of the 8251 which can be set or reset by using this status word. So through this status word, the microprocessor, it can read the status or the internal conditions of 8251. Now let us study the function of these 8 bits, that was this transmitter ready and was these D0 to D7 pins they define. Let us first start with the D0 bit, which was TXRDY, that is transmitter ready. This transmitter ready, it is a pin available at the pin diagram of the 8251. When we studied the pin diagram, we studied the description of this TX ready pin. So this TX ready pin, it indicates that the 8251, it is ready for the transmission of data. Now this 8251, it is connected between the microprocessor and the peripheral device. So microprocessor, if it wants to transmit the data, so this TX ready pin of 8251, if it is high, it means that 8251, it is ready to accept that data which is to be transmitted. Okay, so microprocessor, when it see this pin TX ready, if it is set, it means that data, it will be sent by the microprocessor to the 8251. So here we have, suppose we are having the microprocessor, this is 8251, it is having that pin TX RDY. So when this pin is high, it means microprocessor, it is going to transmit the data to the 8251. 8251 is ready to accept the transmitted data character. So this pin, it can be set or reset by using the status word D0 pin, transmitter ready. Next we have receiver ready. It means that whenever microprocessor, it wants to receive the data, it means the next case will be D1 bit, that is RX ready receiver. Now same 8251, it is acting as receiver also. Okay, here we will have that input output, or we can say peripheral device. That peripheral device, if it wants to transmit the data to the microprocessor, okay, so here it is receiving the data from the input output. So that receiver ready will be indicated by this RX ready pin. Okay, and this can be set or reset by using the D1 bit of the status word. Okay, next we have transmitter empty. Transmitter empty pin in the 8251. So when the transmitter section of 8251, it is empty, then this pin will be set. It indicates that all the data characters which were there with the 8251, they have been transmitted. So all the characters are transmitted. then this pin will be set, and it can be set or reset by using this D2 bit. The microprocessor can read the status of this pin using the D2 bit of the status word. Next we have the parity error D3 bit. Now this bit is set when a parity error is detected in the case of transmission. So this D3 bit, it is defined for the parity error. Now parity error, whenever it occurs, then it is going to set the parity flag, or this D3 bit, it will be set whenever a parity error is detected. Now this parity flag, it can be reset by using the ER, that is error bit of the command instruction. Just like status word, we have control words. So in the control words, we have a command instruction control word. So this control word, it gives command to the 8251, and in this command instruction, we have a bit called ER bit, and if we reset this bit, then the parity flag will be reset. Using this bit, we can reset the parity flag. Okay, so whenever parity error occurs, this bit will be set. Next error bit we have is the overrun error. The D4 bit in the status word is defined for the overrun error. Overrun error means, suppose that 8251, it is having a data that is to be read by the CPU. Now CPU is not reading that data, and again some data has come. So the earlier data, it has been lost. So that is the case of overrun error. So whenever this error occur, this bit will be set, overrun flag will be set. So this overrun error will occur if the microprocessor, if the CPU, it is not reading the data, and again the next data has come. Okay, so this is the overrun error. It will be set, this D4 will be D4 bit will be set whenever this error occurs. Next we have the framing error. Now when the data is transmitted, then framing is done. Framing means that start and stop bits are defined with the data. Start bit will define that from the next bit the data is starting. Stop bit is defining the end of the data. So this framing error, it occurs, this flag is set when a valid stop bit is not detected at the end of every character. Now when the data is transmitted, if a valid stop bit is not given in it, framing is not done properly, then this framing error occurs, and framing error, it is going to set the framing error flag. Okay, so this bit, if we want to read the status of this flag, framing error flag, then we can use this D5 bit. If it is 1, means framing error has occurred. If it is 0, it means no framing error has occurred. So these are the three types of errors: parity error, overrun error, and the framing error. Parity error means that is the parity even or odd, then in that case parity error will occur. Overrun error means data has been not read and next data is available. Framing error means valid stop bit is not there with the data. So whenever these flags are set, the microprocessor can read the status of those flags using these 3 bits of the status word. Next 2 bits we have D6 and D7. So D6 bit, it is for sync detect or break detect. Sync detect is used in the case of synchronous mode and break detect is used in the case of asynchronous mode. So when the this 8251 it is working in the synchronous mode. So in synchronous mode, along with the data, sync characters are also transmitted. So when sync characters are detected, then this sync detect is high, and when the break characters are detected in the case of asynchronous mode, then this break detect will be active. So these are pin at the 8251. 8251 it has a pin for this signal, and we can set or reset that pin using the D6 bit of the status word. We can read the status of this signal using the D6 bit. So these are the functions of this D6 bit. Then we have D7 bit, which is DSR, that is data set ready. Now this DSR is a pin at the 8251 DSR bar. This is an active low signal. Now this D7 bit, if it is 1, it means that this DSR signal, it is active, means its value is 0. Okay, that means the data signal, the 8251, it is ready for receiving or transmitting the data. So if we talk about the 8 bits, we have studied the function of all the 8 bits, what they define. Transmitter ready, receiver ready, transmitter empty. These are for the receiver and the transmitter section. Then these are for the errors, parity, overrun, framing, and these two are also for the receiver and the transmitter. So out of these pins, the D0, D1, D2, D6 and D7. These pins, these bits, they are used to set or reset, or we can say that used to read the status of pins of 8251. This 8251 IC, it is a 28 pin IC. In the pin diagram, we studied all the description of the 28 pins. So out of those pins, some of the pins, their status can be read using this D0, D1, D2, D6 and D7 pins of the status word, bits of status word. And these D3, D4, D5, these are used to read the status of the errors. Okay. So in this video, we studied the status word of 8251 Programmable Communication Interface, which is also known as Universal Synchronous Asynchronous Receiver Transmitter, that is USART. So I hope that this topic is clear to you. Thank you.